Now in this video we want to look at some applications that involve using our linear equations and our slopes. The first problem we have here is the slopes of lines representing annual sales y in terms of x in years. So y is representing our annual sales and x is representing our time in years. Use the given slopes to interpret any change in annual sales for a 1-year increase in time. So if we kind of look at this graphically, what that means, if we have over here, this is our y-axis and this is our x, and down here, y is representing our sales and x is representing our time based on years. So if we think of this as, for part A, we have a slope of 24. So if we mark off here, and I'm just going to randomly pick some point here, let's say that this is maybe 4, and this 4 is representing the year 2004. And then if we want to go from 2004 to 2005, then that means we would use 5 here to represent 2005. Now they tell us that we have a slope of 24, and I'm just going to again kind of randomly pick a point here. So if we have, let's say that our sales happens to be located right here in 2004, and then we have a slope of 24, so that means we're going to increase 24, that's our rise, and then the run, this is understood to be over 1, so then that means we're going to go to the right 1, so that's 1 year, so from 2004 to 2005. Then we want to determine what's happening as we go from one point to the next. Well, clearly, if we look at the line here, what's happening to our sales? It says use the given slope to interpret any change in our annual sales for a 1-year increase in time. So we increase the time here, that's our horizontal, 1 year. So if we do that, we're going to go up 24 in sales. So what that means with a slope of 24, in this 1-year period, our sales are going to increase 24 units per that year. Now, what do you think is going to happen for a slope of negative 36? Well, if we did the same thing, if we were to pick a point, and now we're going to go down 36, it's a negative 36, and again, this is for our 1-year period, so we're going to go down 1 and then over, down 36 and over 1. So then if we look at what's happening here, because our slope is negative, you should have guessed that it's going to decrease 36 units in sales over that 1-year period. Now, what's going to happen if we have a slope of 0? Well, that means there's no increase in the sales. So if we go from one point to the next, then this is understood to be over 1. So now we're not going to go up any at all. We're just going to simply go to the right 1 unit. So therefore, is there any change in these annual sales? And again, the answer is no. So that just means that from whatever year to the next year, there's no change in sales. All right, the next example, we have a pharmaceutical salesperson which receives a monthly salary of $2,500 plus a commission of 7% of sales. And they want us to write a linear equation of the salesperson's monthly wage in terms of monthly sales S. Okay. Now, a lot of times you hear phrases where they say write y in terms of x, so you're thinking of something like y equals some number times x and so forth. So here they want us to use the w in terms of s. So just like we normally would say y equals something, here we're looking at now w rather equals something in terms of our variable s. So in other words, Our W is treated kind of like we normally have our Y, and our S, the monthly sales, is representing our variable X. So how can we come up with an equation for how much this person is going to make? Well, so that means the wages here are going to be equal to how much? Well, we know that they're going to get a salary of $2,500. So that's a given. So automatically they're going to make $2,500. But then it says plus they make a commission of 7% of whatever they sell. Well, if we think of this 7%, we know 7% is really the same thing as 0.07 because percent means per 100. So 7 divided by 100 is 0.07. So then that means we're going to take 7% or 0.07 of what? Well, it's 7% of the sales. Well, our sales is represented by S. So it's 0.07 times S because we don't know what the amount of sales are going to be. We just know that we're going to get 7% of the sales plus this $2,500. So this is the equation. And if I rewrite this in our slope-intercept form, we could think of this as 0.07 S plus our 2,500. And this is our equation. So we're going to get 7% of whatever we sell, plus we're going to get our standard $2,500. Now in this example, we have a school district purchases a high volume printer, copier, and scanner for $24,000. After 10 years, the equipment will have to be replaced. Its value at that time is expected to be $2,000. They want us to write a linear equation giving the value V of the equipment during the 10 years it will be in use. So we know that from the start that our scanner is going to cost us $24,000. Okay, so there's our given information. And we know that after 10 years, the value at that time is expected to be $2,000. So from 24,000 to 2,000, we know then here, this is our time after 10 years. Now, what is the time going to be over here? Well, at $24,000, the value of the printer when we first bought it, no time has passed, so that means at time 0, the value of the printer is $24,000 once we purchase it. And then we're going to expect after 10 years, the value of that printer, copier, and scanner is only going to be $2,000. So how do we come up with an equation to represent the value during this 10-year period? So now, once again, just like we had before, y in terms of x, here we're going to be using, instead of y, v is going to be the value of the equipment, and t is going to be like our variable x. So if we think about this, if we were going to plot this, then you would think of your x and y axis here. So that means on the x-axis, this would be our t for time, and the y-axis is v, would be representing the value of the printer. So that means over here, if we look at t is 0, that's really our x, so we could think of this as at time 0, the value of this printer is $24,000. And then at 10 years, the value is only $2,000. Well, notice now, what do we have? We have 2 points. So if we have 2 points, don't we know how to find the equation of the line? We can think of this simply as x1, y1, x2, y2. And remember, if we want to find the equation of a line, we need to know the slope of the line, and we need to know a point on the line. Well, if we're given 2 points here, we can easily find the slope using our formula. So that's y2 minus y1. So that would be 2,000 minus y1, which is 24,000, over x2, which is 10, minus x1 is 0. So 2,000 minus 24,000 divided by 10 is equal to a negative 2,200. And if it helps you, keep in mind, even though this is a nice integer, this is understood to be over 1. So this is the change in the y. So in this case, this is the change in the value of our printer over the change in the time. So what this is telling us, when we have a negative 2,200, that tells us that in a 1-year period, the value is going to decrease by $2,200. So if we try to set up our equation now, we know that y equals mx plus b, or if we want to keep in with our variables we have, then y is what? That's the value is equal to m times t, where t is our time, plus b, which is the y-intercept. So if we substitute in what we know, then v is equal to our slope times t, so m times t, so it's a negative 2,200 times t plus our y-intercept. Well, now we're in luck because up here, our point 0, 24,000, right here, we have our y-intercept because our x-coordinate is 0. So we could just plug in 24,000. And here we have the equation that represents the value of this printer over the 10-year period. And I've mentioned this already, but I want to kind of re-emphasize this. Here we have our slope, which is basically a negative $2,200. What does that represent? Well, that represents that every year, and this should be actually a negative $2,200. So that tells us that every year the value of this printer is going to decrease by $2,200. So if we start out with the value of the printer up here at 24,000, and then we know that over our 10-year period, so let's say down here this is our 10-year period, then the value is going to decrease, and it's going to decrease as we go from 1 year, it's then going to decrease $2,200. And then if you go another year, it's going to decrease another $2,200. And it's going to keep doing that until over the full 10-year period, it's going to decrease where the value of the printer will only be $2,000. So we know that when we get down to this point, it's going to be approximately $2,000. So keep in mind, if you're given a word problem, what I want you to realize from this example is that if they give you information where you can actually identify 2 points, and that's where we use the $24,000 with time 0, and then we use $2,000 with a time of 10 years. If there's a way that you can pick out points from the given information, you can use those 2 points to come up with the equation of your line. Now, the previous example, they give us an example where they give you the information. You don't have to worry about finding the points. So in this example, they told us that we made $2,500 plus some percent of our sales. So keep in mind that if you're given the points, you can use those 2 points to find the equation of your line.